So as usual this week, as far as this video goes, again, you're going to be given a problem for you to try, and after you give it a try and give your answer, I'll go through it so you can check your work. So let's go. So for this system of equations, there's different methods you can use, and that's one of the things you have to keep in mind as you do all of these. I mean, sometimes, which method you prefer to use is either based off of which one you feel more comfortable with. If you look at certain formats and see that one works better than the other, by all means use whichever one you think works better. For me, this one, when I look at this, it looks like it's already set up for kind of doing elimination. And if I choose to eliminate the y's, because 2 is a factor of 6, they already have opposite signs. That's the easiest way to go. Whereas if I choose to eliminate the x's, I'd have to multiply both sets of both equations by something to get a common factor in front of the x, or a common coefficient. So I chose to eliminate the y's and simply multiply the top equation by 3, making the top equation 9x plus 6y equaling -3. The bottom equation was left alone. So now when I add the two equations together, the y's cancel, and with those 16x equals -48. I divide both sides by 16. I get that x equals -3. And so, at this point I can answer the question, how many solutions are there to the following system of equations? Because, once I get a single x value, I'm going to have a single y value, which you can see here. I showed all the working out. So it does have a set of coordinates where these two lines intersect each other, and therefore it has exactly one solution. Let's go on to the next one. So, and again, as you try to answer these questions about how many solutions are there, the only way you're going to be able to tell and come up with an answer to this is to actually, try to solve it and see what happens. Sometimes you might be able to look at them and see certain relationships and say, okay, well, sometimes it's really obvious, sometimes it isn't. Now for this one here, again, it's kind of set up for elimination. When I look at the x's and y's, looking for common factors, off the top of my head, when I look at 6 and 4, they do have a common factor for the y's of 12. So I'm going to choose to eliminate the y's. But both of them are going to have to be altered. So the top equation I'm going to multiply by 2. The bottom equation I'm going to multiply by -3. So I have a positive 12y on top and a negative 12y on the bottom equation. So when I eventually add them together, they will cancel. And so when I work that through, I get 24x plus 12y equaling 36, and for the top equation, and the bottom equation becomes a -24x minus 12y equals a -36. Now when I add these together, something happens that, that causes a special case. Because on the left-hand side, everything cancels and becomes 0, but it also happens that everything on the right-hand side does the same thing. So I had to put this statement that 0 equals 0. When both variables end up being eliminated through either elimination or substitution, and whatever step you take to eliminate one of the variables, the other one goes away too, that means you have a special case. And the two special cases are either no solution or an infinitely many solutions. And then basically it's based off of what this statement down here is. Now this statement here says 0 equals 0. That's a true statement. And so that means this thing does have a solution. It would be something we would call consistent, but it's consistent and dependent, or it would have infinitely many solutions, because there would be an infinite number of ordered pairs that would make both of those equations true at the same time. Let's have a look at the next one. So for this one here, how many solutions are there to the following system of equations? Again, to answer the question, you have to go through the process of trying to solve it and see what happens. Here I look at the x's. I mean, the 5 and 3, 10 and 6's, I mean, they really don't have any common multiples. They're not factors of each other. When I look at the 5 and the 3, 15 comes to mind as a common multiple. So I'm going to multiply the top equation by 3, the bottom equation by -5, to turn this into a 15x and a -15x. So when I add those together, the x's will eventually cancel each other out. But when I do this, the top equation becomes 15x plus 30y equaling 45. the bottom equation becomes negative 15x minus 30y equals negative 50. So when I add these together, again, the left-hand side, everything cancels, so I'm left with nothing. And that tells me right now I have a special case. On the right-hand side, 45 plus negative 50 becomes negative 5. So I know I have a special case, so it's either no solution or infinitely many solutions. I end up with a false statement because 0 does not equal negative 5. So because it's a false statement and I have a special case, that means that this system of equations has no solution. So, when you eliminate both variables, you end up with a true statement. That's when you have infinitely many solutions. If you eliminate both variables and end up with a false statement, that's what tells you there's no solution. That's how you tell the difference. Let's have a look at the next equation. Now for this equation here, or system of equations, again, I want to determine how many solutions there are. So again, I'm going to go through the process of trying to solve it. Here I'm going to choose to eliminate the y's because as I see here, I have one in front of here and here, so either x's or y's are just as easy. As far as like y is ever so slightly easier to eliminate here because I already have opposite signs for this, whereas this one here I have to make sure that I would multiply everything by a negative to get a negative 3x. It's not a major difference, but I think there's a slight edge for eliminating y's as far as ease goes. So that's what I chose to do. Multiplied the bottom equation by 3, so the top equation was left alone. The bottom equation became 3x plus 3y equaling 12. And so when I add these together, the y's cancel. That means was 6x equals 19, which means x equals 19 over 6. Now, at this point, I already know what this. I already know how many solutions there are because I got x to equal something. Both variables did not get eliminated. I was able to solve for one of them, which means I can eventually just go back, do my substitution in for x, figure out what y is. And so I do get an x and a y value, which represent the coordinates for an ordered pair, where these two lines intersect. So this does a system of equations that has exactly one solution. I don't necessarily have to find the y to do that. Once I get an x value here, that's enough information to let me know that I got a solution for the x's. I'm good. Therefore, I don't have to go any further as far as figuring out anything else about how many solutions there are. So, moving on to the next problem, which now deals with word problems. Let's move on to the next one. So in this word problem, you have a bank in your room that only has dimes and quarters in it. The bank contains 34 coins in total with a value of $6.55. How many quarters are in the bank? So you're looking for the number of quarters, but along the way you might have to figure out the number of dimes as well. So take a moment to try to figure this out and then we'll go through it. Okay, so the trick with these kind of questions, like any other word problems, is to try to get algebraic equations involved so you can have something to solve. And that's what some students sometimes have issues with, is they try to take questions like this in particular and try to just figure it out, trial and error and things like that, which ends up taking longer and you don't necessarily find the right answer. So there's two things that we're looking for. There's one thing we're primarily looking for, but the two unknowns we have are how many quarters we have and, of course, how many dimes we have as well. So since those are two unknown values, one of which is what I'm actually looking for, I'm going to let Q be the number of quarters and let D be the number of dimes. What I want to do now is come up with two equations based off the information that allow me to, write these two equations so I have two equations with two unknowns so I can start using either elimination or substitution, whatever the case may be. So the first piece of information I noticed is that it only has dimes and quarters, so there's no other coins I have to be aware of or worry about. It says the bank contains 34 coins in total, which means the number of quarters plus the number of dimes have to total 34. So I write basically an equation that says that number of quarters plus number of dimes equals 34. The other thing they give us is information about the value that these coins have. So for me to figure out the value I have in quarters and the value I have in dimes, if I did both of those in order to add them together to get the total amount of value I have for the combined total. Well, the value of quarters is going to be, $0.25 or 25 cents, whichever way you want to look at it, for a quarter, because that's what it's worth. So if I want to figure out, how much I have in quarters, I would take the number of quarters, which is Q, and multiply it by 0.25. And I would do the same thing with the dimes, but except that their value is 0.10 or $0.1. And so I would take 0.1 times D, the number of dimes, to get how much money I have in dimes. And of course, when I add those together, I should get $6.55. So that's where I get this equation. The value of each quarter times the number of quarters will give you the amount of money I have in quarters. The value of each dime times the number of dimes is going to give me the amount of money I have in dimes. Adding those two together is going to give me the total amount of money, or value of money I have in this bank. And so now I have my two equations with two unknown values. Now I had to come up and solve them. So what I chose to do is, because it's slightly easier, because Q and D, they both kind of lend themselves, with having a coefficient of 1 in front of them for being the variable I eliminate. But 0.1 is easy to work with, because all I do is basically multiply something by 0.1, you move a decimal point to the left. That's pretty easy to work with without having to take out the calculator or anything yet. So I decided to eliminate the D. The other reason is because if I eliminate D, I'll end up with Q, the number of quarters, right, automatically, and that's what I'm looking for. It's this one here I'm primarily looking for. So that's the other reason why I chose to eliminate dimes. And so I multiply the top equation by negative 0.1 on both sides. And so my equations become, the top equation becomes negative 0.1Q minus 0.1D equals negative 3.4. And the bottom equation was left unchanged, so I add them together. And the D's will cancel, leaving me with 0.15Q equaling 3.15. I divide both sides by 0.15, and I get that Q equals 21. I could go back and figure out the number of dimes if I want to, but you're not asked to find that. You're asked to find out how many quarters there are, and that we do have. You may want to figure out what the dimes are so that you can put those values back in, make sure both of these equations work, but through checking on your own. But basically there are 21 quarters in the bank based off of this information, and that's your answer. Try one last word problem for the end of this practice, so here it goes. So here, you're given that two numbers add up to 20. If one of the numbers is 3 times the other number, what are the two numbers? So here you're actually looking for both numbers. Now, they don't tell us what these numbers are, and there's ways you can handle this with only using one variable, but you could also use two variables. I mean, so some of the mixture problems that were actually done earlier, a couple of lessons ago, you could actually set up using systems of equations as well. Questions like this could even have been answered because this is like a mixture problem. It's a mixture of two numbers. But basically, since there's two unknown values, there has to be two facts I know about them that lets me write these equations to come up with them. So the first piece of information I have is that these two numbers add up to 20. So I'm going to let the two numbers be x and y because I don't know what either one of them are right now. And I know that x plus y should add up to 20. The other piece of information is that one number is 3 times the other number, which means I'm going to let y be the bigger number. It doesn't really matter which one I let be what, but y is going to be 3 times whatever x is. And so with these two pieces of information, I can now solve this system of equations. And since this bottom equation is already solved for one of the variables, in this case I am going to use substitution. So I'm going to use this equation here, and I'm going to redefine this equation. So I'm going to replace the y with what it equals. It equals 3x. So I have x plus 3x equaling 20, which means that 4x would equal 20. Dividing both sides by 5, I get that x equals 5. And going back to this bottom equation here, y equals 3 times 5, because that's what x is. That means that y is 15. So both of them do add up to be 20. This is 3 times the amount, so these are the two numbers. So the two numbers are 5 and 15. And that is the end of this practice. If you have any further questions, please reach out and get a hold of me. Until next time, have a good day.